I would like to talk a little bit about the research domain criteria, the RDoC project of the NIMH, which is a very important and welcome project trying to relate brain systems to mental disorders. And it is extremely important because it could offer the basis for a future brain-related diagnostic system. In this project, there is an attempt to relate sets of signs and symptoms to specific brain systems. For example, based on findings today that certain systems are relevant to certain symptomatic manifestations. For example, the amygdala involved in anxiety disorders and so on. I think this project stands a risk to have an approach like in the past, a localistic approach of the brain where specific mental functions were related to specific brain regions. Thus, specific mental disorders will be attempted to correlate with specific brain systems. And in order to avoid this kind of risk, I think that it is very important to introduce a dynamic, complex approach of computational neuroscience and neural networks, also because we know that the brain is a complex such system of neural network dynamics. And to look at these systems more as systems that have to do with regulating whole brain organization and whole brain dynamics. For example, I think the RDoC will have a big problem trying to tackle disturbances which have to be probably related to whole brain organizations, such as personality disorders. For example, we know today that the brain can represent information. We know that the Hebbian algorithm is the mechanism that allows the brain to store information, and probably whole brain continuous storage of information allows the brain to have an internal model of the external world and also of the external psychosocial information. Thus, every one of us can have an internal model in the brain that guides us and helps us adapt to the real occurrences in the environment. So typically, if we have a good, flexible and matching presentation to the external events, then we can act upon these external events in an effective manner and in such a way that we adapt and we gain effective activity. If there is a mismatch, if there is a discrepancy between what happens in the real world and the internal representations, then a non-adaptive behavior begins, and there is and this kind of mismatch between external and internal information causes us to act in a non-adaptive manner, and thus in a way that that causes suffering actually, and that can arise as tense, anxiety, or depressed mood. So how can the brain represent such a whole world internal representation? This is probably related to massive connectivity structures that allow the brain to store information. And today we have a lot of information about, a lot of data about the default network that probably represents some kind of connectivity structure that represents the internal representations. Now, if we assume that personality disorders are disorders that result from some kind of mismatch or discrepancy between the internal representations of psychosocial activities and what really occurs in the environment, then such a mismatch needs to be somehow explained scientifically and work like the work of Giulio Tononi, talking about matching complexity, is very intriguing and very interesting to relate to that. For example, we know that by using neural network models and systems, that the internal statistics of connectivity is shaped by the input, by the coming input, and this can actually create a good match between the input and the internal representations. So we can start and use this conceptualization to try and take something very, very complex like personality disorder, and using massive interacting systems like the brain and the idea of matching complexity as described by mathematical models of neural networks, and start reconceptualizing personality disorders as disorders of matching complexity. So by this kind of conceptualization, I'm trying to start and see how we can take something complex as personality disorder and relate it to brain structure, function, and dynamic organization. You can read more about this daring approach in some recent publications, for example, the neuroscientific psychiatric diagnosis and the neurophysics of mental disorders. And there is also a book titled Neuroanalysis that tries to systematically and scientifically relate complex neural disorder, mental disorders to their brain-related dynamic systems.